Hi dear, I'm Ahmed Monofy and I'm a PhD student at Politecnico di Torino, and I'm speaking today about the effect of river flow and groundwater discharge variation on hyporheic zone characteristics in alternate power. So first of all, what is the hyporheic zone? So the hyporheic zone is the transition zone between the river domain and the groundwater domain, and this zone is special because it's very active in terms of biochemical reactions. And we are studying it in alternate bar morphology type, or polar riffles as some researchers call. What we are investigating exactly here, so we are looking at how is the effect of river flow variation on these hyporheic zone characteristics, as well as applying gaining and losing conditions from the ground water domain. So what are the characteristics that we are looking at in the hyporheic zone? First of all, we are looking at the hyporheic flux, which will tell us how much solute matters will transport from the river domain into the hyporheic zone. And we're looking at the residence times, hyporheic residence time, which tell us how long those solutes will reside within the hyporheic zone. And then we are looking at also the hyporheic depth, which will tell us how much is the penetration of the hyporheic zone within the groundwater domain. So what we did, we built a numerical model, and in order to build this numerical model, we had to go through 3 steps. The first one is that we have to define the alternate bar geometry, and we make it more representative for most of the real conditions. And then we had to run a surface water modeling in order to get the pressure head distribution on the stream beds that will work for us as upper boundary condition for the groundwater domain. And then we had to run the groundwater modeling in order to get the real hyporheic zone characteristics that we spoke about before. So when we look at the results here, so first of all, when we look at the pressure distribution, we see that the pressure distribution variation is stronger when we have lower river flow. And when we look at the hyporheic zone itself, we found that we have 2 hyporheic zones, not only one. The shallow hyporheic zone where the flow passes move quasi-laterally through the polar refill sequence, and demonstrated here by the blue lines. And we have the deep one where the flow passes move longitudinally under the peaks of the alternate bars. And when we look at what is the effect of the different of the increasing the river flow on the hyporheic flow, we see that when we increase the river flow, the hyporheic flow decreases, which means less solute matters will transport into the hyporheic zone. And when we see here the commutative distribution of the residence time of the flow passes within the hyporheic zone, we see first of all that the commutative residence distribution follows a bimodal, which proves our hypothesis that we said before, that we have 2 flow passes groups, so we have 2 hyporheic zones. And the deep hyporheic zone is not affected, as shown here, is not affected at all by the river flow variation, while the shallow one, the residence time increase when we increase the river flow. And when we look at the depths, we see in general that the hyporheic zone depth decreases when we increase the river flow discharge. And here we are investigating the effect of groundwater in terms of gaining and losing. And we see in general, when we apply gaining or losing conditions, the hyporheic flow decreases, and also the hyporheic area. And the hyporheic area is the exchange area between the river domain and the hyporheic zone. And also when we look at the residence time and the depths, we see in both deep and shallow zone, the hyporheic depths and the hyporheic residence time decrease, but they decrease in different rate. That's why we have to investigate, or we have to look at them separately. And we look here at very strong groundwater magnitude. The bimodal commutative distribution here shifts from bimodal shape into unimodal shape, which implies that eventually the deep hyporheic zone will disappear and we will have only the shallow hyporheic zone. So we conclude that first of all we have two hyporheic zones, shallow one and deep one, and we have to study them separately because they do have different characteristics, even though the trends are the same but the rate is different. And we conclude as well that we cannot use only one river flow condition to be a surrogate for all other river flow conditions, because each case is different. And that's what I wanted to explain today, and thank you for your attention.